Okay, here we go. I'll keep warning you about this. You're working on problems that talk about f prime, f double prime. Do not make the sad mistake of thinking you are looking at f prime when you're looking at f. So don't go fast, go slow. We are looking at f. It says at what value of x is f continuous? Don't read slow. Do little things at a time. So let's just check this for a minute. Where is f continuous? So everybody raise your hand. Is f continuous at x equal a? Raise your hand, please. Is f continuous at x equal a? Raise your hand. Is f continuous at x equal a? Let's go, Cole.
Yes.
Cole says yes. Who agrees? Two more. At x equal a, f does not have any discontinuities. F does not have a jump, removable discontinuity, or vertical asymptote. Therefore, at x equal a, f is continuous. So far, so good. Raise your hand if you can tell me any places where f is not continuous. Hands up. Places where f is not continuous. Let's go, Annalise. At x equal b, what kind of discontinuity do we see, Annalise? So that's a removable discontinuity. And then anywhere else, Annalise, where f is discontinuous. And what kind of discontinuity is at d? That one's a jump. So how many knew we had a removable at x equal b, and we had a jump discontinuity at x equal d? How many knew that? Two more, okay. We want to talk about any of that. Awesome. At x equals c, f is continuous. At x equal e, f is also continuous. So now we can keep reading some more. At one of those three places, f is not differentiable. It says, at which value of x is f continuous but not differentiable? Continuous but not differentiable. Okay, differentiable means you can find the derivative. Derivative is another name for tangent slope. So if I go looking here at C, we did this on Desmos. If you zoom in on that point, raise your hand again. If you zoom in on that point, as you get closer and closer on that point, will the curve continue to look like a curve, or will the curve more and more appear to be flat? Hands up. If you zoom in on that point, Kennedy, what do you see?
It'll be flat.
It looks flat, which means we can find the slope at that point. We can find that. How many knew? Two more. Okay. So we can find that slope. That means f is differentiable at x equals c. The slope is findable. F being differentiable means you can find the slope at that point. Questions? Okay, notice the difference at A. Hands up again. If you zoom in on A, this is what I call a corner. I don't think that's a math word, but I think it's a pretty good description. When you zoom in on a corner, does the corner do what we did here, where the curve eventually looks flat? Or does the corner, no matter how much you zoom in, always look like a corner? Hands up. There we go. Let's go, Hugh. Trying to agree. Two more. So you get this little dilemma. You're like, well, on this side of the corner, the slope is the yellow. On the other side, the slope is the blue. They're never going to be the same. So if you're doing the Desmos thing where you're trying to make the secants shorter and shorter and shorter, here they become shorter and shorter, and they become the same slope. Here they do not. So the correct answer is A, because at x equal a, the function is continuous, but at x equal a, the function is not differentiable. There's a box on the notes to help you with that. On the notes box, you can ignore the equation for now. That will show up in Unit 3. But this part you have to memorize for the Unit 1 test. The function to be differentiable must first be continuous. So Everybody look at me. What that means is this. It is impossible for a function to be differentiable at a point, but not continuous at that point. That can't happen. For the function to be differentiable, it must first be continuous. Also, once we know the function is continuous, the function can't have a corner and it can't have a vertical tangent. At x equal a, we have a corner. That's why the function is not differentiable at that corner. Please.
Is the vertical tangent the same as the vertical asymptote? Is that just the same thing?
They are related but not the same. Vertical tangent would mean this, too, for Noah. It would mean the values of f, the xy pairs, at one point have a slope that is straight up and down. And because we don't know how to quantify or give a number to that slope, we say that f is not differentiable at that point. Questions? Oh, yeah, please.
I don't know if you just said this, but why wouldn't it be E?
So 2 more for Kate. So at x equal e, we said the function is continuous. So now we want to see if the function is differentiable. One way to do that is just ask yourself, is there a corner right there, Kate? No, corner would be where the graph of f changes abruptly, something like that. Or here's another example of a corner. Here's another example. Those are all corners. So no corner. It's also not a vertical tangent. That means it is differentiable. We can find the slope. Another way to look at it is if you zoomed in on this spot, the curve would stop looking like a curve. It would look straight, which means we could find that slope.
Okay.
2 more for Kate. Anybody else? Okay, let's keep going. Stop that.